Hello friends, and welcome to Chat from the Engineering Desk. So today's question is, can you take an Arduino, an OLED display, and put it behind a smoke glass window and make yourself a shift knob for your car? The answer is kinda, because as you can see, it's not very visible. So pop this out. There's our little window, smoked acrylic, and there is our OLED display, which I'm running off SPI. It's an SPI display, so it fits into this recess over here, and you pop the acrylic over and you fit the bezel, and that should be very pretty, but OLEDs are not bright enough for the job. Let's turn down the lights and see what it looks like. There's one light off. There's another off, and there's another off. So basically at night you'd be able to see this in your vehicle dimly, but it needs to be brighter. So it'd be better off. Look, the nice thing about this is that the light's coming back. Watch your eyes. The OLED can of course be programmed, well, controlled with the Arduino over here to display different things here. Like when you're in reverse, you could use sensors to detect which gear you're in and display the gear selection. You can do all sorts of interesting stuff. But the display itself, it was something I saw and bought, and I thought, that would make a cool project. And things don't always work out. One of those things, but you learn something from it. Now you know what is OLED good for and what you should not use it for, like this. Anyhow, why don't we have a quick look at the code, and I'll show you how I drew that, and then we'll conclude this video. See you at the PC. Alright, so here I've got the code. You're going to need Adafruit GFX library. You will need the library for the SSD1331H, which is the controller used on that OLED display, and you'll need SPI.H because it's an SPI communication to the display. Then you configure your I/O, which is clock, data, clear to send, reset, and DC. Then you need some colors. So over here there's your colors in hex codes, some basic colors. So you then initialize the library, and here's where it all happens. You say display begin, and that begins the communication with the display. You say full screen black, that basically wipes the screen black, gives the black background. So now I'm going to write the letters, the numbers to the screen first. So there's gear 1, gear 3. There's their positions, by the way. It's X and Y. So it's 44 pixels X or 0 Y for number 2. So that's the bottom of the screen. And you do all your numbers, your 4 gears. There's number 5 as well. Let's pretend it's a 5-speed stick shift. And then you have reverse, and I made that red. Then you need some lines, so I made them all blue. So you got your X and Y start coordinates, then you got your width and your height, and you got your color that you want it to be. And this is an empty loop, so it writes to the screen, and that's it. That's all that this code is doing. So let's have a quick look at how I designed that shift knob. There's 2 parts to it. So over here is the knob itself. I've got it set to transparent, so you can set see the inside stuff and what's going on there. I started off with a cylinder, and then I pulled it, and it was a 50 millimeter cylinder. So if I hit E, we'll have our dimension there, and I made it 25 high, and then I did a round pull 25 millimeters high, and it gave me half a ball. Then I added another cylinder to the bottom, and I filleted it. The radius was 8 millimeters. That over there is a 20 millimeter diameter. I put a hole up the middle, that's 12 millimeters, and then I added the dimensions for the screen to fit in. So that over there is 31.5 millimeters, and that over there let's measure from there to there. So click that one, rotate, control, select that face, 28 millimeters. So that's the dimension of the screen if you want to make a recess for it. It's 31.5 by 28. And then this dimension over here was 40 millimeters. And then I just gave it some inner clearances for the wires and stuff. Fooled around a bit there. And that's how that came out. Then it needed a bezel. So there's your bezel. I made it E for dimension 39.5. So I gave it a little half a millimeter of clearance so that it would fit into the knob. Now I know that the knob in this dimension is going to print half millimeter smaller. That's why I designed this with half a millimeter less. The outer dimension was the same. It was 50 millimeters. And then I rounded it off. That inner dimension was 33 millimeters. And that was that. Then I used a jigsaw to cut out a piece of acrylic, and I sanded it on the disc sander till it was down to 40 millimeters and a nice good fit for the acrylic, which was a piece of scrap which I found in the scrap pile. The Putting a display behind some smoked acrylic works very nicely, but you're going to need a fairly bright display, and unfortunately the OLED isn't suited to that task. So let's have a look at the wiring of the SPI display. Let's hide that. And then when the confuser decides to come to the party, we can have a look at that image. I really need to put an SSD into this confuser and give it some more RAM, as it were. So there we have it. We're putting 3.3 volts onto the display to power it, and then pins 8, 9, 10, 11 and 13 are your data lines going to the screen. And that's the electrical connections to the screen. And on the product image it looks nice and bright, but in reality that's not quite what you're going to get when you use the this OLED. So just be aware of it. It's suited to low light conditions, and yes, it has its uses. The shift knob is unfortunately not one of them. So that's that over there. That's how that panned out. It's still a useful exercise in doing creative work. You're learning. The outcome might not be what you hoped for or what you planned, but you got some practice in 3D design. You got some practice in the coding over here, like that. It's a nice simple program. And you got to make something, and it's a departure point for other projects, because you can take this and modify it. So it's not all in vain. It would have been quite nice if the display was nice and bright, because a shift knob with a darkened screen and the H pattern nice and brightly displayed would be quite pretty. Unfortunately, it doesn't work like that in this case. Need to use a different display, or use a printed image and backlight it with a white LED. That would also work. The only thing is that then it's static, so you can't change displays and that sort of stuff, which is the motivation for using a display. So anyhow, I think that's going to conclude a little talk on a shift knob with a display in it. We all learned something out of this. It was a useful exercise, regardless of the outcome. Ladies and gentlemen, have yourselves a wonderful day further. I'll see you here back next time for more. Thank you. Cheers.